Thank you. You should now be seeing the second poll appearing on your screen shortly. Thank you, everyone. And now for one final polling question before we kick off the rest of the webinar. Thank you. So thank you very much, everyone, for answering those polls. Now, without any further ado, I'd like to introduce our panel moderator today, Don Cowan from EDF Renewable Services, who will be taking you through the course of this webinar. Just to stress again, ask any questions using the questions tab so we can get to them later. But other than that, Don, the floor is yours, and good luck with everything else. Thank you.
Thank you very much. And thank you for everyone for joining the webinar today on lifecycle strategy and planning in the PV space. Thank you also for everyone who participated in providing feedback on the previous poll questions. We have found that having clear definitions between stakeholders involved in the O&M planning on items such as plant sizes that require full-time staffing and where to plan for future circuit enhancements creates streamlined strategic decisions on events that occur throughout the plant's life cycle. Thank you very much. On today's webinar, over the next 40 to 45 minutes, we'll be covering, one, what are the gaps and challenges O&M providers like ourselves have found while working through with asset owners. We'll discuss strategic considerations that should be made when approaching O&M decisions. And then we will drill down to remote and field specifics led by Ben Witt and Mike Smith, respectively, before concluding the webinar. First, to give a kind of a brief introduction about EDF-RS and our contribution to the solar O&M space. EDF-RS operates around 1.5 GW of solar assets across North America. RS began in the wind sector, and we operate another 8.5 GW across North America. EDF-RS is a part of the EDF group across the globe, around 160,000 employees. And we view O&M strategy through an owner-operator perspective. We ensure O&M decisions result in positive results for projects' profitability and for asset owners and stakeholders. I wanted to start off with some lessons learned EDF has taken from the wind space. As I mentioned, we have a large fleet in the wind sector, and much of our strategy and perspective is derived from servicing wind farms. Wind turbines have the ability to produce high visibility for remote operations and performance engineering processes through the use of robust SCADA systems. When servicing generation assets, the more granular you can become available, the quicker you can identify and resolve issues, therefore reducing man hours. As we kicked off the webinar a moment ago, having a clear understanding of benchmark about which parameters and project size or what manufacturer and equipment is being used, this generally drives efficiency when looking at a fleet operations. One of the key components and differences in wind is there's generally a primary OEM, the original equipment manufacturer, that engineered the majority of the generation equipment to work as a collaborative system. When these assets are not engineered as a full system, but a collection of different pieces, this can generally lead to some higher failures and then higher costs. These learnings from wind can help steer the direction and efficiency of the PV O&M space. So what are the missing pieces? What are those gaps when approaching the O&M space? O&M providers such as EDF RS and others have identified a gap in specifically the planning stage for many owners. These gaps in planning and the budgetary stage lead to some unaccounted for costs across the project lifecycle. This results in lower performance and reduces the project profitability for owners. In addition to these financial concerns, there's also cause and strain on the business relationships if these risks are not properly communicated from contractors, asset managers, and any party affiliated. This is the primary point of today's webinar, to call attention to some of these essential, but not every gap, that asset owners should be aware of when making O&M planning decisions to maximize the project's performance and profitability. So next, we'll go into general overall asset strategy considerations. Safety first, always. Safety is your ticket to play in this industry. Not having a behavioral and cultural-based safety perspective leads to potential incidents, which above all can harm your greatest asset, your people. I want to really reinforce this behavioral and cultural component of safety. Programs should not be designed in a way where you need to be in compliance with a standard or a process, but instead it's a way to go about your business and empowering the team to go about their daily routines in a safe way. One of the ways you can do this is generally planning for time to have those safety be discussed among teams. Also planning ahead for additional PPE advancements that can help technicians in the field. Another gap we've come and found is when we've seen copying and pasting scopes and procedures across geographies. This starts at the highest level by country, and there are more regional components of the local jurisdiction. Be sure to understand the energy and regulatory landscape of a region. For example, this could be planning for additional time for interconnection or energizing the substation in Latin America. Other examples of this are having specific certification requirements in Canada, or being aware of additional soiling concerns that occur in Chile due to fog and dust that cakes on the modules requiring additional washings. Make sure to analyze where your fleet is going over the next few years, rather than just where your project is now. You want to make sure that you are making decisions that will negatively impact your operations and add additional costs when moving into another region. Another common gap we have found is regards to having a clear definition of what comprises a site that requires dedicated staffing, which we could define as a manned project, and what can be serviced by a remote team or a part-time staffing, an unmanned project. As we touched base at the beginning of the webinar, there's certainly some variation from the poll questions and moving forward on what is the right amount of staffing. And as there's no formal wrong answer, knowing what is the appropriate amount for your organization helps to benchmark quality and costs when assessing new projects. From our experience, common staffing benchmark we use is around 1 tech to about 40 to 50 megawatts with a minimum of 2 techs for safety components with some geographical differences. One O&M design gap for manned projects that can be overlooked is where the O&M facility will be located on site. If it's situated in a far corner compared to a centralized location, this can have a large impact on reducing or increasing the amount of man hours to complete maintenance activities. When a project has dedicated staffing, the primary objective is to use this dedicated staff to prioritize their time, focusing on the most impactful events and faults. When you have this dedicated team, you really need to optimize their time and the impact of activities and ensure availability requirements. In contrast to a manned project, optimizing resources on an unmanned project, such as in the C&I space, commercial and industrial, requires every corrective task to be analyzed through a financial lens. Unfortunately, we found a common gap is for new solar asset owners, if they receive an operational performance report with some minor losses or faults, to send out technicians to assess each issue as they arise without a thorough assessment of the cost-benefit analysis. This can rapidly increase project costs, and in some cases, produce minimal production gains. A thorough remote analysis should be completed prior to determine if the items can be consolidated together with other work orders, preventive maintenance activities, and if a call is needed, being able to anticipate remotely what parts and equipment will be needed will also help avoid multiple trips. Another consideration when developing your O&M strategy: when you should bring in different parties like asset managers, construction managers for pre-COD support, O&M contractors, and any others being involved in the project. If you bring them on too early, you can incur unneeded costs, or bringing them on too late causes some handoff issues at project milestones. For example, assigning an experienced asset manager to be a stakeholder in reviewing O&M contracts can really help pick up on scope overlaps before the contracts are finalized, which can reduce any unneeded fixed fee scope items. Though it can be difficult in a fast-moving development process, connecting these for more efficient handoffs can reduce challenges on punch lists, delivers proper project documentation for future handoffs or any asset acquisitions. Effective O&M strategies incorporate a plan for as many milestones as possible. Some milestones that sometimes have gaps in proper planning can be the following. For example, commissioning pre-COD activities. The timeline of these tasks can greatly impact other elements of the contractors. So the more you can iron out and align these timelines, you reduce the need for any standby charges or delays. Health checks. We've seen these can be sometimes looked at as a nice to have versus a requirement. But properly planning for them can increase project profitability. For example, having a third party come in to inspect the equipment at the end of a warranty is generally commonplace in the wind sector, as we found. But in solar, we often see inverters do not get the same level of attention, but they do have the same level of impact on a project's success. Detailed performance assessments by performance engineers can pick up on small trends that lie deep within your data, which generally can result in some high returns. And recalibrating your models is another effective health check. This should generally happen by every 5 years or so. Module manufacturers commonly define module degradation of around about 0.5% annually. It can change. But through the specs you may be stating one thing, the degradation is not often as linear as defined. Recalibrating your models to account for this can avoid you chasing down some production gaps that aren't really there or attributing some overproducing systems to incorrect parameters. For major components, inverter replacements, generally they're pretty accounted for, but having a plan on how this is handled toward the end of your project term, as Kara pointed out, we want to make sure that it can be a little bit different sometimes. Panel washing is a common item that can be overly planned for also when it truly isn't needed. Ownership flips or asset acquisitions, this can change some of the directions of O&M strategy and can add additional costs if a transition is not executed properly. Though force majeure events are not generally something you plan and budget for in detail in every event possible, just being aware of what these risks are and having a plan in place in case they do happen can limit the exposure. Planning for the project's end of life. As we really see, this is the future trend, and as these projects are coming near to the end of their system life, it's going to be more up in front. We want to make sure this is not something that can up in mind during development, but we want to make sure it's coming to fruition now. Things to think about as you're moving through a project life or even through the project. If you have a PPA, can you renegotiate it? Or is merchant a proper option moving forward? The system specifics and the parameters can play a large part in determining if repowering is a good option as well. Ground mounts, repowering is a really true good option. While roof mounts may have an aging roof and structure repairs can be required, which makes it less viable. All of these are just some of the milestones that should be considered when developing an effective O&M strategy. As we discussed earlier, having a clear definition of what activities and tasks are handled by which party avoids any scope overlap and efficient operations. Next, we'll drill down to specific O&M components such as remote operations and performance engineering, and then field ops in the supply chain. With that said, I'd like to hand it over to Ben Witt to discuss some of the remote strategy considerations.
Thank you, Don, and thank you all for attending this and keeping your attention. I'd like to just start this off by just discussing what we define as remote operations and performance engineering here at EDF. Starting with remote operations, what we mean is really your control center and the support team that basically makes sure that the back end is up and running. So types of items that are included is curtailment coordination, SCADA support, again, that back end support, of course, around-the-clock monitoring and remote notifications, fault resets, and event reporting. Basically, any actions that can happen remotely that don't need somebody on site and kind of need to be happening all the time. From a performance engineering standpoint, we're talking about trend analysis, reporting and engineering support. The actual people that'll take a deep dive into some of those few percent performance issues, as well as identify some of the key issues that impact your solar site, and then make sure that people are coordinating that. So starting off with remote monitoring. Remote monitoring in the wind side has been a mainstay for quite some time here, where the solar side has been kind of slow to adapt. So one of the things, just to start this off, is, what are we adding? Remote monitoring is adding safety, regulatory, and performance requirements for your site. There's a lot that gets added with regards to monitoring a solar site as regulations change and as different performance requirements are added to your actual assets. So the three keys that we have to stay at the cutting edge is, one, improve efficiency by delivering actionable data and lower response time. Really, your remote operations should be as automatable as possible, and you want everything operating very quickly and very efficiently for both the different business units that are involved in your O&M strategy, as well as the different asset management owning units. The next key is reliability. You have to improve reliability through repeatability, using your SCADA aggregations and using a standard look and feel for your remote control center operators. I can't stress that enough. You have a team of people looking at a number of assets and a number of different SCADA systems. You need to make sure that their job is repeatable and what they're looking at is understandable. And then, of course, the third key is to add value. So we add value with performance monitoring, customized alerting, and notifications. We add value by doing custom different checks that we can do on the site, as well as building out different systems to make sure that there is a process, either automated or procedural, that will actually add value to your site. So kind of touching on how we're reaching those goals more, we use a standard SCADA overlay. So one of the things that we see as a large control center or a larger control center is that we have a lot of different SCADA systems installed on site. This is a huge thing in the solar space. As Don was touching on earlier, the OEMs in the wind space come with a full stack of software that go along with their assets. In the solar space, we don't see that. A lot of times people are installing customized or adaptable SCADA products that are different from site to site and installed different even if they are the same software. It's a surprising thing to see people using the same SCADA software across even their own assets, let alone different owning groups. The other thing we do is try and enhance the tool set for our remote monitoring team, and this includes performance tools like Truelytics, which we use, and there's other ones on the market that give you a smarter way of looking at your site, as well as an enhanced view of what alarms you should be creating for your SCADA overlay system. And finally, of course, you have to standardize as much as possible to reach any sort of operational excellence or do anything in a repeatable manner. So we heavily stress standard operating procedures and our training for our team in the remote monitoring world. So moving on from there, one of these enhanced tool sets, like we were mentioning, is our Truelytics. Basically, we're giving you a quick one sheet view for different owners. It's a powerful tool for being able to see quick things like late startups, clipping, understanding what's going on with curtailment, viewing your graphs over time, being able to understand of what should happen versus what is happening. Again, you get a lot of polished KPIs that are actually delivered for different users, from asset management and the reports they want to see, performance goals they want to hit, to site personnel seeing faults and events and frequency to see bad apples, to your remote operations team saying, is this a weird event? Is this abnormal? So talking a little bit more about that, what is performance engineering from how we define it? From an EDF standpoint, it's providing that tool set for our OTC, our asset management, and our field teams to monitor and alert on performance goals. Now, a lot of this is business specific, but it does start with safety. So right off the bat, you want to have a real-time system that's being able to notify and understand what's going on to your site from a BOP level as well as an asset level while guys are out on site. You want to understand that those standard operating procedures and your interaction between the field and the OCC and the performance engineering team can help build on that. Next is you want to understand your operational assessments. Operational assessments are a mainstay in the wind industry, I would say at this point, but they're going to become an important aspect of the solar industry as well as you start trying to quantify what's going on with your site. Don was mentioning earlier in degradation, but degradation can impact your site in many different ways, and it also can be a very misleading cause for any of your few percent performance dips over time. So performance engineering helps to identify those areas of poor performance. Your late startups, your curtailment, your clipping, your degradation, and provides the actual people to make sure you're looking into this and work with the appropriate OEMs or work with the appropriate field team to actually look into this and see what's going on. A lot of these things are actually very fixable and get left and unfixed for years on end, which are hurting your bottom line in a large amount. So how does this all work? First, it starts with establishing baselines. There's one set of expected production that comes with the site after development, and then there's another one that hits when you're actually when the boots are on the ground and the money's being made and the power is being generated, and seeing what that actually is and how that changes over time can be quite eye-opening. So the two things that kind of hit you right off the bat are the plant events and the asset equipment. You got to pay attention to your main breakers, your metering, make sure that everything's actually running and power is actually flowing. And then also a large section is what's going on in your asset equipment. How much information do you get off the inverters? Do you get any information from the lower side, from the recombiner level? And how does that impact what you can present? Presenting data and reports with polished KPIs for different users is one of the most powerful things that we've seen. Being able to change and grow those requirements into actual reports that people can repeatedly see and understand the other impacts of what's going on with their page is absolutely critical. We see things like the data gaps here on the triangle and minor loss trends being major key things to look at when you're staring at a monthly report. What data did I lose and how much data did I lose? What are the actual quantifications for those losses over different times? Were they impacts on data quality or were they impacts on actual power quality? And lastly, one of the most important things is to set up and follow a business process. This goes with what Don was mentioning about specifying who's responsible for what and the different stakeholders. You need to have a process for how to deal with issues that you see. There's a lot of different ways, or a lot of different stakeholders that can view one centralized portal or SCADA system on site. You want to know who's the throat to choke, so to speak, with that business process, and who should be looking at what and who should be fixing what. So moving on from that, the next thing we're going to discuss is kind of the back end of that remote operation, which is your SCADA and networking. So SCADA, Supervisory Control and Data Acquisition, is what it stands for. Basically, it's what's making sure your plant is still running. Without any data, you don't have any monitoring, you don't have any reporting, and you don't have any performance review. We've seen some very bad instances of this where you are not being paid because of your lack of data. So this can become overlooked very quickly as it's not a primary view, but when you don't have it, everything comes crashing on around you. So the two main impacts of quality that we see are that you should be paying attention to is what is your data quality and what is your data availability. From a data quality standpoint, the things you should be asking, the questions you should be asking is how reliable is your network, your hardware, and your software infrastructure. From a data availability standpoint, and this is big in the solar space, how many devices are smart and how many of them are actually on the network? Where are all the different places I can get data? Again, this is very different from the wind space, and that individual assets actually tell you a lot about what's going on. Here, inverters have reduced data maps, and getting data beyond the inverter can be quite difficult if you're not planning those requirements early on and understanding that there is a lot of money being left on the table when you don't dive down and get information on the next level. So how do you decide what to do? What's the best way to do this, and how do I spend my money? You know, and understanding that mentality, right? First, you want to define a strategy ahead of time that allows for clear decision making. You want to set requirements during your development process. Pre-COD is one of the most malleable sections of your development where you actually have CapEx budgets before things are actually tied down to being specific. So that's one of the huge parts is knowing what your requirements for operating the plant before you're finished with development. Documentation for turnover can be critical. A lot of times here you're having different parties involved and a complete turnover who's taking care of your software and your infrastructure, and that documentation can be absolutely critical so that people aren't doing new discoveries every time there's an issue. Further down that line is you want to define clear device and software responsibilities. You want to make sure you know who to go for different problems and what pieces of equipment actually are responsible for different functions. And the next thing to consider later in life on the project is it worth doing a replace or an upgrade to the equipment that I have? So those are all kind of difficult to see, but they're things to weigh as you move forward. And to help you kind of decide over what is an important thing and what is a less important thing is you want to understand the requirements from the other business units. And that starts with the asset management, reporting, billing, and invoicing. They're the ones that are going to be the closest to understanding what the money is and what the budget is. The next is the field availability and performance reporting, is what are the requirements from the field crew to actually provide and be able to do their job, and does any of the downtime or issues impact their ability to do their job? And lastly, of course, how does any issue or any requirement impact the OCC monitoring requirements? One of the simplest things is what is the onboarding of an OCC? It's good to be important to realize that you can actually take quite a bit of time to integrate completely with an OCC and make sure that they're following all of their requirements and scope. So with that, we're going to dive into a case study. This is actually all from one site, but it was one of our worst ones, so it's not necessarily a status quo. This is just kind of to walk through some of the things that you see and then walk through how we can fix it, and then, of course, touch on the impact that this can have on your site. And again, if you were kind of following or asking all the questions that we were talking about earlier, this will kind of solve itself before it becomes that problem. So starting off, from the takeover of this site, and this was an older site that we took over after some years of operation, we saw from the network side that the site was directly exposed to the internet. So as we kind of grow into the new regulatory requirement world, this becomes extremely sensitive. There's a large growing cybersecurity or threat to the cybersecurity of your site as well as the grid in general, and there's a lot more eye-opening that goes with that. So, previously plants may have just exposed themselves to the internet as ease of monitoring and ease of flexibility, and now we want to get into the world where we're actually in a managed site and a managed security for that site, so you actually have the appropriate people reaching it, and your critical infrastructure isn't exposed to any of the hackers or viruses that are roaming the internet today. So the next one is the next major issue that we saw in the network standpoint is that the central network management, the actual router firewall, was a proprietary software-defined solution, and there was no turnover documentation with regards to admin access, and it was not a standard equipment with regards to configuration where someone could use like a Cisco device that generally people could understand or learn and you have an expertise in-house. So this is one of those where you let the previous owner let kind of the R&D or freelance guys run in a little bit amok with how they wanted to install things and didn't take a close look at the actual long-term infrastructure and how it's going to be supported over that time. And the last one is we had a slow and intermittent ISP depending on the time of the day. We actually signed up like a regular house user as if you were having your own internet at home, which is fine for smaller sites, but it presents you a different set of issues with regards to data acquisition and with regards to remote monitoring as well. So on the SCADA side, what we were seeing is routine failures of the site SCADA, which was causing a lot of gaps in remote monitoring and data acquisition in general. This was getting frustrating to the standpoint in Congress with the intermittent ISP that it would take hours, there'd be hours and hours of the day where no one was monitoring this site in attempts to actually reconnect to the site SCADA to see it. And then data coming off the site from that centralized SCADA system was dropping out even more frequently, providing basically a endless please help me, the system is down request from our control center and our field staff, which basically is overburdening your site with SCADA engineers like myself or network engineers like our NetOps team, actually trying to dive in and look into the issue when there's not much we can actually do to fix it, besides say maybe give it a 30 minutes and try again. So this is one of the main gaps here with the impact for our OCC and our field operations. From the data availability side, we were missing access, administrative access to any of the PLCs below the inverter. So this is one of those things you want to know when you're talking about performance monitoring. If you don't have that next level of monitoring, the water that's coming to your faucet before it's at your faucet, you don't understand much beyond the inverter, and you can lose multiple percent before really realizing how it's impacting your overall production. And you can start seeing issues and prioritize issues if you have that. The other thing that we saw with that is that it had a whole lot of intermittent network connectivity based on the settings that it had. So we were constantly losing these PLCs after we had taken over admin access. And the next step is there was a missing integration of BOP equipment into the SCADA. So what we mean is the balance of plant equipment. How we define that is kind of your feeders, your relays, your main breakers, your transformers, and your meter information. Basically, all that comes up into your one line. Like one of the most important things that you need to make sure is all up and running was not integrated into the SCADA, and all you had was asset monitoring. So kind of quickly going through here to talk about the fix. Of course, this is not the main point, but basically anything is fixed, but what it does is adds cost to what's going on, and you want to make sure that if there are problems, people are responsible of it. So what we did from the IT side is we rolled out a new network router and firewall. We did a reevaluation of the internet access. We ended up, following the least privilege implementation for access, which is kind of one of the IT security best practices now. We shut down, 99.99% of the access to the site and restricted it to only the ports and specific people that needed it. Yeah, this added a high cost to the project. We ended up doing a lot of additional equipment purchases and a lot of man hours for that actual reconfiguration and re-engineering of that site. From the SCADA standpoint, we rolled out a new data aggregator controller. Again, you're adding a bunch of costs to the project to actually rip and replace systems that are neglected. We removed reliance on the existing site SCADA, kind of touching on that ISP issue. We weren't able to actually remote desktop into the site SCADA on a consistent basis. So we had to switch the way we were getting that data and how we were integrating that. We added some additional access to data, so we're doing data interface configuration here on these last three, but we were able to fix the issue. But one of the main impacts we had off this is that a main breaker opening was actually missed due to this issue, where both the field and the OCC were confused on whether or not someone was monitoring the site. And you went, a good amount of time before someone actually dove in and said, hey, wait, is the site actually supposed to be off? Is this maintenance? Is what's going on? Who is monitoring it? And this all comes from having a poor infrastructure. So you got to make sure that you're paying attention to your infrastructure, because otherwise your site could be offline with nobody knowing and no one understanding what it means from that site system. So moving on from that, the last thing we're going to talk on the back end side is trends for the future. What you should be paying attention to kind of as we're moving forward. One of the things that we like to discuss is future-proofing your software and data systems, which results in could be costly upgrades at first if you are future-proofing, but extremely expensive and time-sensitive upgrades if you don't think about them in the future. Basically what we see here is you have a 20 to 30 year life cycle of your project, but you have a hardware and software cycle of 3 to 5 years. So one of the big analogies we like to say is, how long do you keep your cell phone? And you should kind of keep that as a guideline of how long you should keep your SCADA system, or at least take a look at it and see if it's still working. One of the big things that we see coming in here from an industry best practice from the IT side is the virtualization. A lot of solar sites are not set up on modern IT infrastructure and are still kind of stuck in the industrial PC environment. The industrial PCs are more difficult to manage and difficult to upgrade. You end up just having to buy new equipment, and although it saves you money on the front end, you lose flexibility moving forward. So that's one of the main considerations we take, especially for larger sites, is what is your hardware infrastructure, and make sure that it is flexible for the future with regards to the specifications, i.e., adding RAM or hard drive or CPUs to it, and making sure that it supports different versionings of your servers that are running on your virtualized hardware. Windows updates are becoming a requirement for larger facilities with NERC regulations. And kind of moving into that, there's a lot of those NERC regulations that add a cybersecurity best practice and business process to your operations, which actually rely on a lot of upgrades to your system that we ended up having to do like we went through in that case study. Another thing is, from a data availability standpoint, increasing data requirements are coming from ISOs as well as different business units. So being able to have a flexible network and a flexible hardware solution to support the software that's running on there is absolutely critical without having to buy new hardware every time someone asks for something. So understanding and planning for these increased requirements is essential to increase profitability and decrease risks. Hopefully we went through that quite a bit here, so you can kind of understand what questions to ask from the back-end standpoint and the remote and performance monitoring side. So with that, I will pass it off to Mike with the field strategy considerations.
Thanks, Ben. So a great update from Ben on remote operations, performance optimization, and how that affects the planning of your facility from a communication and data system standpoint. So go ahead to the next slide. And the next slide. Oh, well, we're going to talk about us. That's what we're going to talk about. We're going to talk about the boots on the ground, the frequently forgotten fact that we have men in positions to work on equipment, and that's what makes the money come in from an electrical revenue standpoint. We'll also get into a little bit of supply chain, because you have to have components, parts, and tools, and all that other stuff for those guys to use. So Ben spoke quite a bit about data and how important it is to optimize and plan in your data systems to get that data flowing in. Well, why is that? Why do we need all this data? Well, what we actually need is actionable information. And of course, that's where the performance optimization folks come in, where they convert that data into information, and that aids in planning. A lot of solar parks are smaller. They don't justify on-site staff, and every time you roll persons to that site, you're spending money. So you've basically got two choices. You can plan the communication infrastructure, you can plan the remote operability structure of that facility in order to minimize the number of field trips, or you can hire an O&M provider who happens to have an office right outside the front gate, because travel time to sites to keep up availability to ensure that you capture all that available solar radiation costs a lot of money. The other solution, of course, is to plan those trips better and to have very well-designed systems that are remotely operable. Once you get that information, you do have to make sure you define who does what, so to get clear communication from the folks that are turning that data into information out to those field folks, and they can use that in their planning, so they make sure the number of trips that they have to that facility are minimized. We also want to prioritize. Some problems are big problems, and some problems are small problems. Some problems result in the loss of electrical generation, and some problems do not. We want to make sure we prioritize those faults that result in no generation before we prioritize those that would be nice to fix and maybe are causing some data glitches or whatever that might be, but are not affecting generation at that point. Next slide, please. Further communicating on the planability and the efficiency of that boots-on-the-ground field crew, the design of your system has been alluded to, with more information coming in from more remotely located components in that system, the more fruitful that visit from that field technician is going to be. One of the greatest or the latest trends that we've seen that's really gaining traction and is probably going to be the industry standard within a short period of time is aerial IR scanning by a number of different means. The science behind photovoltaics tells us that each panel has a different heat signature depending on whether it's working at its specification or not working at its specification. These photographs, as you see in the slide right here, can be taken with such high resolution and with such global positioning accuracy that we can immediately tell, even before the technician's boots hit the ground, exactly what component in that system has failed. When that technician goes to that site, it's just a matter of him or her going immediately to the problem and fixing the problem. It greatly reduces mean time to repair and thereby your operating cost. Having this type of inspection planned into your O&M costs up front in your pro forma will most certainly make your model more accurate and be more effective in the future. Go ahead to the next slide. Don spoke of the fact at the beginning of the presentation that when you buy a solar facility, you're buying a set of components drawn together from various industries, various manufacturers, and assembled into a solar facility. That means that your erector set has pieces from manufacturer A, manufacturer B, manufacturer C, all increasing the likelihood that you will have a difficult time procuring these parts in the future. So, again, plan for that obsolescence, plan for that difficulty in supply chain, plan on having inventory if you don't want to deal with those issues in the future, or at least not in the near future. It's possible to custom manufacture components, but it's much more feasible, much more cost-effective to have a plan up front where you understand what you are going to do to deal with the life cycle of components that may or may not be available when the time comes to replace them. Next slide, please. Don't forget the other stuff. This is not unique to solar farms. Every industry has those things that aren't directly in the value chain but somehow need to get done. Otherwise, the roof falls in. Solar parks are no different. Depending on the area of the world that you are in, you may have vegetation that would like to grow up over top of your solar farm that needs to be taken care of. You could have such dry conditions that the dust settles and never washes off, greatly reducing the efficiency of your panels and increasing your costs from panel washing exercises. And for sure, you have a meteorological station. The data from that station is critical when doing performance guarantee calculations. Temperature and irradiance need to be understood clearly. That requires calibrated instrumentation, which means that the supply lines for calibrated instruments and the means and the methods for and the frequencies for changing out those instruments need to be defined up front. These are not insignificant costs if you do not model the fact that you need to replace instrumentation up front and end up doing it every year. Your facility will incur thousands, if not tens of thousands of dollars in cost in order to keep up those instruments that you rely upon for information for adjusting the cash flow back and forth based on performance. Those are just a few examples of ancillary services, and they're very dependent on where your solar farm is located at. Next slide, please. Okay, your solar farm has a lifespan. Understanding what the lifespan is of that solar farm up front, as well as what the drivers of the end-of-life decision-making will be, is critical. There are many choices to make, but the bottom line is the drivers are generally the same. Is your power purchase agreement expiring at a certain date? Do your leases with your tenants or with your landowners expire at a certain date? Are you in a growing or declining electrical market? All of those inputs drive cost-benefit analysis decisions and are weighed against the fact that as your park ages, you'll have increased maintenance costs, you'll have increased parts procurement challenges. If your PPA becomes null after a certain period of time, it may involve increased market risk. If you are decommissioning those components and need to clear the facility to an as-was state when it's finished, said and done, there may be hazardous material costs associated with getting rid of components. All of these drive whether you want to continue to run your park, cannibalizing equipment and reducing its output, but keeping the remaining equipment running as effectively as possible. Repowering your facility to have the latest and greatest technology and continue to supply a growing market if that's what you're lucky enough to have. Or perhaps even trying to maintain the output of your facility through a lucrative or at least a profitable PPA past its useful life or its defined design life. This will probably require some amount of custom manufacturing to keep up with old component failures that you expected to have happen, but nonetheless need to be dealt with. End-of-life decisions, as I said, are usually based on a certain number of inputs that don't change much from park to park, but they do have to be weighed against cost considerations and the details of those inputs to make sure that we understand fully what the costs of the end-of-life of that facility will be. Next slide, please. Those are the types of planning that are necessary to ensure that those men, the boots on the ground, they're going to take care of your facility, have the best information, an adequate amount of supplies, and can get the work done to keep your facility up and running, but in an efficient fashion to keep your O&M costs low. Since we've ran through those, I'll turn this back over to Don, and Don will close up our webinar with a few thoughts.
Thank you, Mike, and thank you, Ben. To summarize some of today's key points, as there was certainly a lot. One is gaps in O&M planning lead to increased costs throughout the project lifecycle, which generally can reduce the project profitability and the project performance. Creating a defined strategy to manage the asset prior to commercial operations ensures greater efficiency. This includes bringing the appropriate stakeholders at the right time and understanding the geographical differences that affect the approach. Robust and increased data collection and automated analysis accelerates the identification and production losses, allowing you to pinpoint and prioritize issues that focus on items that have the most impact. And last but certainly not least, streamlining field operations processes by utilizing data and incorporating new technologies such as aerial IR scans can reduce man hours and increase the project profitability. I want to again thank everybody for joining today. And I hope this webinar brought really some attention to some of those gaps that we've seen in other ISPs across the industry. We want to make sure that asset owners are aware of these when making O&M planning decisions to maximize the project's performance and profitability. With that, I know we have a few minutes, 1 or 2 minutes for questions, so I'd like to take the first question. Kara, I hand it over to you.
Thank you very much, Don, and thank you very much to everyone else. That was a fantastic webinar and had an awful lot of questions coming through. So I've got the first top 5. Now, if anyone else does have any questions that they would like answered by the webinar panel, feel free to keep sending them in, and what we'll do is we'll make sure that EDF gets a chance to review and write a reply to those questions for you at any point. I know that 1 or 2 of you have been asking probably about 6 or 7, so we'll just make sure that you do get the answers that you need if they're not answered within these questions now. So, got a couple of questions. Let's start with an easy one. How many? What was the size in megawatts of the plant shown on the front cover of the presentation?
Could certainly do that. It's around 110 megawatts peak.
Magic. And then again, early from within the presentation, can you repeat again what was the man per megawatt ratio that you talked about?
Great. Yeah, this definitely can vary per company and organization and specifically for region, but the baseline we use for the United States is around the 1 tech to 40 to 50 megawatts. And this kind of is on the western, California region, I see that baseline to be starting from. That can definitely change. We also have a 2 technician minimum for safety components on our utility sites.
Okay. And how actually feasible do you see a 30-year life cycle for a PV plant? Is that a realistic target?
I would say, certainly yes. I want to pass it around to the rest of my group because as we've seen, again, we know panels and PV has been around for some time. We have panels from the 60s that are continuing to produce. Now, I think there's some gaps on what the expected production losses will be. That will change, and I think we'll learn more, but the actual operations of those units will certainly withstand. Ben, or any other comments there?
Not much. Maybe Mike can chime in. You're going to be talking about, retooling and repowering and upgrading along the way. It depends on kind of your market and how beneficial it is and how good your PPA is if it continues to be that long. So there's a lot of things to consider, but it's definitely an option.
Perfect.
Ben hit on the head as far as the cost-benefit relationship there, in that, if you got the PPA to drive it, you can do just about anything. Keep in mind with a 0.5% per year degradation, you're already looking at a 15% degradation in your panel. So if everything else was perfect, you've already got down to 85% of your output. So there's a lot of factors to consider when you're considering design life and maintenance life as well.
Perfect. So here's a bit of an interesting question. So there's an awful lot of talk around utility scale energy storage and PV. So what kind of impact do you see right now on O&M budgets and on O&M considerations for the potential add-in of energy storage as retrofits and in the design of new plants? How do you imagine it affecting energy storage, affecting O&M right now on existing plants and for new plants as well?
So certainly a large question, but at bringing as much as consolidating that I can is ways to be efficient is trying to reduce the amount of manpower on site. Now there's a lot of crossover and there's some not that can be serviced when it comes to storage compared to solar assets, but if you're able to cross-train your fleet to service those sites, that's going to drastically help. Of course, there's going to be some customization now that you have medium high voltage on a solar site that you typically would bring in a specific individuals. That's going to continue with your storage. But routine maintenance, visual inspections, the continued process they're going to hit on a daily basis, you want to make sure you're optimizing with the same personnel to reduce those costs.
Smashing. Two questions left to go. So here's an interesting one where obviously within the wind industry there's an awful lot more talk about machine learning and its impacts within our operations and maintenance, particularly within all the new systems that we're seeing being invested in. So what kind of outlook or plan does EDF have for predictive analytics and machine learning applications within PV, potentially?
Ben?
Yes, interesting question. I think that's straight on. The wind assets are way ahead in this realm. Generally on the upfront, right, you have from the solar standpoint a much more dependable resource, so you're actually at a way better understanding of when it should be doing a certain thing. But generally we're leveraging a aggregated data centralization method to try and tap into machine learning and let machine learning do machine learning and see what it can tell us. It's a big part of our interaction with our performance engineers, and what they actually work on is trying to actually look at large sets of data of certain sites and over lots of sites and, you know, categorizing by different manufacturers to actually see what we can do. I can't say we have any real deliverables on the solar side on that standpoint, so I think it's still early. But as the technology grows, you're going to be trying to leverage as much as you can, and I guess we'll see what comes out of it.
Perfect. And then the final question, and this is actually to each of the panelists in turn. Can you provide each of you one key takeaway for the webinar registrants to take away with them today? If they could only take away one thing, what would each of you say that would be?
I'll kick off. Now, my view is just understanding there is a lot more of what you maybe don't know. And going into it that things can change and having some flexibility and the different stakeholders are part of the project, know things would change, and then you really want to have a full view across what may happen, not just one option, but multiple options of what that life will look like across the plant. Ben?
I would say to understand the business process for the O&M world and who the right stakeholders are to and whose throat to choke, so to speak, for different issues.
Mike?
Sorry about that. It's the life cycle issue. You need to understand, as Don points out, that you need to define those key drivers to your life cycle decisions up front, have multiple stress models that show you different happenings that you might incur 10 or 15 or 20 years down the road based on what those inputs do as far as from one extreme to the other.
Perfect. Well, thank you so much, everyone, for your time. Just some final remarks from me. I mean, thank you to everyone involved and to EDF Renewable Services in making this webinar a huge success. We've had over 800 registrants for this webinar, and over 200 of them actually participating today, and we've had in excess of around 50 questions, which has been absolutely fantastic. And I really hope that you've gained more than you hoped to get from this expert panel. And the recordings, as I say, will be sent to you in an email in the next few days. From the discussion today, I mean, what's clear is that the long-term value of PV investments could be crippled through a lack of understanding on operations post-COD and how to successfully optimize performance of PV across its life cycle. This is why more than 300 of the industry's most forward-thinking utilities, IPPs, developers, OEMs, and innovators are all gathering at the 4th Annual PV O&M USA 2017 Conference and Exhibition this November in San Jose, California. They want to discover the changes they need to make right now to optimize their revenues and profits right now and in the future. Major stakeholders nationwide are already confirmed, and you should see a link in the bottom left-hand corner of your screen showing you to the website to find out more information. I really hope that your team can make it, but do get in touch with me directly if you have any questions at all. Again, thank you for everyone for your massive help in this webinar. It's been a huge success, and we can all go home. Thank you. Good night and goodbye.
Normally they'll come back.